Hey everyone, welcome back to the channel. If you're prepping for DP 700 Microsoft Fabric Data Engineer exam, you're in the right place. Today we're diving deep into one of those classic questions that shows up all the time, Delta Lake Timeable. Okay, picture this. You've got a product inventory table that gets updated constantly throughout the day. Prices changing because of promotions, stock levels shifting with sales and restocks. The analytics team comes to you and says, hey, we need to compare how prices looked on different dates. Specifically, show us exactly what the data looked like on January 15th, 2023, and also let us see the very original version of the table before anyone touched it. And you, being the Spark developer, need to give them two different ways to pull that historical data, one using a date and one using the version number from the transaction log. So here's the question we're tackling today. A Spark developer is implementing a time travel solution for a product inventory table that undergoes frequent price adjustments and stock level updates throughout each business day. The business analytics team needs to analyze pricing trends by comparing product prices at different points in time, specifically retrieving data as it existed on January 15th, 2023, and also accessing the original version of the table before any modifications were made. The developer must implement two different approaches to retrieve historical data, one using a specific date timestamp and another using the version number from the transaction log. And here are the 5 options. Option 1, df equals spark.school, open quote, select star from inventory timestamp as of 2023-01-15, close quote. Option 2, df equals spark.read.format, parentheses parquet, close parentheses dot option, parentheses version as of 0, close parentheses dot load parentheses file slash inventory, close parentheses dot option 3, df equals delta table dot for path parentheses spark, files slash inventory, close parentheses dot history, parentheses close parentheses dot option 4, df equals spark dot read dot format parentheses delta, close parentheses dot option parentheses version as of 0, close parentheses dot load parentheses files inventory, close parentheses dot option 5, df equals spark.read.format parentheses delta, close parentheses dot option parentheses timestamp as of 2023-01-15, close parentheses dot load parentheses files inventory, close parentheses. All right, now that we've got all the options in front of us, let's break this down step by step, because time travel in Delta Lake is actually super cool once you see how it works. First things first, what even is time travel? Delta Lake keeps every single change you make to a table in a transaction log. Every time you write, update, delete, or merge, it creates a new version without overwriting the old data files. So you can literally go back in time and query the table exactly as it looked at any previous point. No need to take manual snapshots or duplicate storage. It's all handled automatically. Now there are 2 main ways to do this. One is by version number. Think of it like checking out a specific commit in Git. Version 0 is always the very first state of the table, right after it was created, before any changes happened. The other way is by timestamp. Way more intuitive for business folks because they think in dates, not version numbers. So looking at the options, which ones actually give us real historical data we can analyze? Let's start with the correct ones because that's what we really care about. Option 4 and option 5 are the winners here. Both of them start with spark.read.format delta. That's crucial. You have to tell Spark you're reading a delta table, not just plain parquet files. Then option 4 uses version as of set to 0, which pulls the original version before any modifications. Perfect for that show me the table as it was first created requirement. Option 5 uses timestamp as of with the date January 15th, 2023, which gives the snapshot as it existed on that exact day. Delta Lake looks through the transaction log, finds the latest version committed on or before that date, and reconstructs the table for you. Boom. 2 different approaches, exactly what the question asked for. Now, you might be wondering why the others don't work. Let's quickly go through them so it all clicks. Option 1 looks tempting because it's SQL and mentions timestamp as of, but the syntax is off. In actual Delta Lake Spark SQL, you write from inventory timestamp as of 2023-01-15. The clause comes after the table name, not jammed in the middle like that, so it'll just throw an error. Option 2 tries to use version as of, but on Parquet format. Parquet by itself has no idea about versions or time travel. That's all added by Delta Lake. So even though the option name is right, applying it to plain Parquet won't do anything useful. Option 3 calls history on a Delta table object. That's great if you want to see a list of all versions, when they happened, who made the change, that kind of metadata. But it doesn't actually load the historical rows into a data frame you can query or join. So it's not giving you the data itself. So yeah, only 4 and 5 get the job done properly. Here's why this matters in the real world. Imagine trying to figure out why pricing analytics suddenly look weird. Or your finance team needs to audit what prices were on a specific date for compliance. Or you just want to compare today's inventory against how it looked 6 months ago. Without time travel, you'd be stuck taking backups or building complicated change tracking tables. With Delta Lake, it's literally 2 lines of code. And the best part? It's efficient. Delta doesn't copy all the data for every version. It reuses files and only adds what changed. So you get all this power without blowing up your storage costs. If you're studying for exams or working on real projects, remember, always use format Delta. Pick version as of for precise control or timestamp as of for date-based queries. Time travel is one of those features that makes Delta Lake feel almost magical once you start using it regularly. Here's the next question we're working now. A team wants to query Fabric Lakehouse data for reporting. Which tools allow exploration without modifying underlying data? And the options are option 1, SQL Analytics Endpoint, option 2, Power BI Direct Lake Mode, option 3, Notebooks with Delta Write, option 4, Data Flows with Save Output, option 5, Pipelines moving data nightly. All right, pause for a second. Think about what the question is really asking. You've got this beautiful lakehouse full of Delta tables sitting in one lake. Bronze, silver, gold layers, all nicely organized in that medallion style. Analysts need to poke around, run queries, build reports, slice and dice the data, but nobody wants them accidentally overwriting curated gold tables or creating a mess that breaks downstream dashboards. So we need tools that are basically read-only by design. Let's deeply explore the concept of read-only data exploration in Microsoft Fabric's Lakehouse within the context of medallion architecture. Microsoft Fabric unifies data engineering, science, and analytics in a single SaaS platform built on one lake, a unified storage layer. The Lakehouse item in Fabric is a Delta Lake-based storage that supports open formats like Parquet and Delta, providing ACID transactions, time travel, and schema enforcement on lake data. In medallion architecture, data flows through layers. Bronze layer, raw, unprocessed data ingested from sources, preserves original fidelity for auditing. Silver layer, cleaned, validated, and conformed data, often denormalized for efficiency. Gold layer, business aggregated, curated datasets optimized for reporting, e.g. star schemas. Exploration without modification is critical here because analysts query gold-silver layers for insights, but any write could corrupt curated data or violate governance. Read-only tools query directly against Delta tables in OneLake without staging copies or imports. SQL Analytics Endpoint, a T-SQL-compatible endpoint exposing the Lakehouse as a read-only SQL database. Users connect via SSMS, Azure Data Studio, or Power BI, running select queries, creating views, or building semantic models, all without altering files. Power BI Direct Lake Mode, a groundbreaking storage mode in Power BI that queries Delta tables directly in fallback mode, no import copy, delivering real-time performance on large data sets without data movement. Contrast with write-capable tools. Notebooks, Spark, allow df.write.delta for modifications. Data flows, Power Query can save transformed outputs. Pipelines orchestrate ETL with potential writes. Let's try to understand the question. Reporting team needs to query Lakehouse data, Delta tables in one lake. Core requirement is exploration and querying without modifying underlying data. No writes, transformations that save back, or data movement. Medallion architecture emphasizes separation of transformation, engineering, and consumption, analytics. Goal is to identify tools that are inherently read-only for safe, governed access. The question highlights a common enterprise challenge, enabling broad analytical access to Lakehouse data while protecting data integrity. In Fabric, Lakehouse data resides in Delta format, versioned and governed. Reporting often involves ad hoc queries, dashboard building, or semantic modeling On gold layer tables, the emphasis on without modifying underlying data rules out tools that involve writes, e.g., saving transform datasets or orchestrating loads. This ensures no accidental overwrites, like maintains audit trails via Delta history and supports multi-user concurrency. The question tests understanding of Fabric's toolset separation, engineering tools, notebooks, pipelines for transformation versus analytics tools for consumption. Now let's talk about the two that actually fit the bill perfectly. First up, the SQL Analytics endpoint. This thing is awesome. When you create a Lakehouse in Fabric, it automatically gives you this built-in SQL endpoint that exposes all your Delta tables as a regular SQL database. Analysts can connect with SQL Server Management Studio, Azure Data Studio, or even from Power BI, and just run select queries all day long. They can create views, write complex joins, use window functions, whatever they need. But here's the key, it's completely read-only. No insert, no update, no delete, no dropping tables. The underlying Parquet and Delta files in OneLake stay untouched. It's like giving someone a window into your data warehouse without handing them the keys to the front door. Second, Power BI Direct Lake mode. Okay, this one blew my mind when it first came out. Normally in Power BI, you have import mode, copies the data in, or direct query, which can be slow on big tables. Direct Lake is this hybrid magic where Power BI queries the Delta tables directly in OneLake with basically zero latency. For smaller dimension tables, it might cache a bit, but for your big fact tables, it falls back to direct querying. No data movement, no copies, no imports into the data set. The source stays exactly as it is. Analysts get real-time numbers, sub-second refresh on massive datasets, and zero risk of modifying anything. It's perfect for those gold layer semantic models everyone builds for executive dashboards. Now, why do the other options not work for this use case? Notebooks with Delta write? Well, the clue is right there in the name. Spark notebooks in Fabric are incredibly powerful for data engineering. You can clean data, transform it, merge, upsert, but you can also very easily write back to the Lakehouse with df.write.delta. That's great when you're building silver or gold layers, but it's definitely not read-only. Same thing with data flows. If you're using Power Query to transform and you hit Save Output, you're writing new tables or overwriting existing ones. Not what we want for pure exploration. And pipelines. They're fantastic for orchestrating nightly loads, copying data from bronze to silver, running notebooks in sequence, but they're not a querying tool at all. You're scheduling activities that move and transform data, not just reading it. So yeah, only the SQL Analytics endpoint and Power BI Direct Lake mode give you that safe, governed, no modification exploration the question is looking for. Your data engineers can spend time curating high-quality gold tables, set proper permissions at the workspace or item level, and then let dozens of analysts loose with total confidence. No more, wait, who overwrote the sales fact table? Panic moments. Everyone gets fresh, consistent data, and governance stays rock solid. If you're setting up a new Fabric workspace, I always recommend starting with these two tools for your reporting layer. Give analysts the SQL endpoint for ad hoc stuff and Direct Lake datasets for formal dashboards. It's clean, it's fast, and it keeps everything nice and tidy. All right, that's it for today. If this cleared things up for you, give the video a thumbs up. It really helps the channel grow. Drop a comment below. Are you using Direct Lake mode yet? Or do you still lean more on the SQL endpoint? I'd love to hear how your team's handling this. Don't forget to subscribe and hit the bell so you don't miss the next Fabric deep dive. Thanks for hanging out with me, and I'll catch you in the next one.